Now that you have designed key management using Azure Key Vault, Encryption, and Secrets architecture, you are ready to design the thing those keys ultimately protect: your data. Data architecture is where cloud value and cloud risk meet. If you design data well, you enable analytics, modern applications, and faster decision making. If you design data poorly, you create compliance exposure, security incidents, performance issues, and disaster recovery failures. Your goal in this lecture is to build a leader-friendly, architect-defensible blueprint for storage, database choices, backup, and security patterns on Azure. With that context set, you need to define data architecture beyond product names. Data architecture is the set of decisions that determine how data is stored, accessed, protected, governed, retained, and recovered across its lifecycle. Leaders care because data is a business asset and a legal liability at the same time. Architects care because data choices become long-lived constraints that shape performance, availability, cost, and integration patterns. When you treat data architecture as a strategic design discipline, you prevent quick storage decisions from becoming multi-year technical debt. With data architecture defined, you now start at the right place: data classification and business value. Not all data deserves the same controls, cost, or resilience investment. Customer identity data, financial records, operational telemetry, and public marketing content have different sensitivity and different compliance obligations. Your job is to establish data classes and align them to security requirements, retention expectations, and access models. Leaders appreciate this because it ties controls to business value. Architects appreciate it because it turns vague security demands into clear design requirements. With classification set, you now address the most common mistake: choosing a data service before understanding workload shape. You choose a store based on access patterns, consistency needs, latency requirements, and operational expectations. For example, object storage is excellent for unstructured data and large files, while relational databases are designed for transactional consistency and structured queries. When you choose services based on workload shape rather than familiarity, you reduce cost, improve performance, and reduce risk of later migration. Leaders care because wrong choices increase time and spend. Architects care because wrong choices create long-term constraints that are painful to unwind. With selection principles clear, you now establish a practical mental model for storage patterns. Object storage patterns support documents, images, backups, analytics data, and data lake scenarios where scale and durability matter. File storage patterns support shared file access and lift and shift workloads that depend on file shares. Queue-based patterns support decoupling, smoothing traffic spikes, and improving reliability through asynchronous processing. The leadership message is that storage is not one thing. The architectural message is that you choose the right pattern to improve resilience and scalability without overcomplicating the platform. With storage patterns anchored, you now focus on relational database patterns because many enterprise systems still depend on transactional integrity. Relational patterns prioritize consistency, reliable transactions, and structured querying. Your design considers how to separate operational databases from analytics workloads, how to scale read-heavy use cases, and how to align database resilience with business criticality. Leaders care because databases often power revenue and customer experiences. Architects care because database choices influence application architecture, migration complexity, and disaster recovery design. With database fundamentals clear, you now introduce a critical enterprise principle: separate transactional workloads from analytics workloads. When analytics queries run against operational databases, performance becomes unpredictable and outages become more likely. A mature data architecture designs a pathway where operational data remains stable and fast, while analytics uses curated copies or pipelines designed for reporting and exploration. Leaders value this because it protects critical systems from reporting spikes. Architects value it because it improves performance and creates clean boundaries for governance and cost control. With workload separation established, you now address lifecycle because data problems often appear months later, not on day one. Data lifecycle design covers how data is created, updated, archived, and deleted. It also covers retention rules based on regulation, business needs, and risk. Leaders care because retention affects legal exposure and storage cost. Architects care because lifecycle affects architecture choices, such as whether you need immutable storage for evidence, whether you need archiving tiers, and how you handle deletion requirements safely. With lifecycle in view, you now bring backup into the architecture conversation because backups are often treated as an operational checkbox. Backup is part of data architecture because it shapes recovery time objective, recovery point objective, and business continuity. You design backups to match workload criticality, and you ensure backups are protected from accidental deletion and from malicious tampering. Leaders care because backups are a last line of defense. Architects care because backup strategy must align with data stores, recovery patterns, and operational processes, or it fails when you need it most. With backup strategy defined, you now apply security patterns because data exposure is one of the highest impact risks. You design least privilege access for data, ensuring only the necessary identities can read, write, or administer sensitive stores. You design private access pathways so sensitive data services are not reachable through public endpoints when not required. You design segmentation so data stores sit in protected zones and are not reachable from every workload by default. Leaders care because data breaches become headlines and legal events. Architects care because security patterns must be consistent and repeatable across many teams. With access patterns clear, you now connect data architecture back to encryption and key management because data protection is not complete without key strategy. You ensure data at rest is encrypted, and you define when customer managed keys are required based on regulation and risk appetite. You ensure data in transit is protected through secure transport and consistent trust configuration. Leaders care because encryption is a compliance and reputation safeguard. Architects care because key dependencies must be resilient and operationally mature, or they create new points of failure. With encryption covered, you now address a risk that leaders increasingly care about: integrity. Data integrity means you can trust that data has not been altered unexpectedly, either through malicious actions or accidental change. Your architecture uses auditability, controlled access, and monitoring to detect unusual data operations. This matters because some incidents do not look like outages. They look like incorrect business decisions caused by corrupted data. Leaders care because integrity affects decision quality and trust. Architects care because integrity controls must be built into access and logging patterns from the start. With integrity in focus, you now address resilience because data availability and data recoverability are often the hardest parts of disaster recovery. You align data recovery approaches to recovery time objective and recovery point objective, choosing replication and backup patterns that match business commitments. For some systems, near real-time replication may be required. For others, daily backups may be sufficient. Leaders care because data loss can be more damaging than downtime. Architects care because multi-region data design affects consistency trade-offs, application behavior, and costs. With resilience covered, you now bring in cost because data platforms can become one of the largest cloud spend drivers if unmanaged. Cost is shaped by storage tiering, retention, replication, backup frequency, and analytics processing. You design cost control through lifecycle policies, tiered retention, and careful separation of workloads so expensive compute is used intentionally. Leaders care because data spend can grow quietly. Architects care because cost-aware design prevents future budget shocks and protects the credibility of the cloud program. With cost discipline set, you now define governance because data architecture fails when ownership is vague. You establish data ownership roles, access approval responsibilities, and accountability for classification and retention decisions. You also align data governance with platform governance so policies can be enforced consistently. Leaders value this because it creates compliance confidence and reduces risk acceptance by default. Architects value it because clear ownership reduces conflict and speeds delivery, since teams know who can approve access, who can approve retention, and who is responsible for data quality. With governance in place, you now ground the patterns in a realistic scenario. Imagine a customer service platform stores sensitive customer records in a relational database, and the business wants near real-time reporting for operational insights. Without good architecture, analytics queries hit the production database, causing performance degradation, and a hurried fix exposes data through a public endpoint for convenience. In a mature data architecture, production and analytics are separated, private access is standard, backups are protected, and least privilege access is enforced. The business gets reporting without compromising customer experience or security posture. This is how good data architecture prevents both outages and breaches while still enabling business outcomes. Let's now discuss the key takeaways from what you learned so far so you can design data architecture on Azure with confidence and credibility. Data architecture is a strategic discipline that determines how data is stored, protected, governed, retained, and recovered across its lifecycle. You start with data classification and business value, so controls and investment align to sensitivity and impact. You choose data stores by workload shape, using storage patterns for unstructured data, file patterns for shared access needs, queue patterns for decoupling, and relational patterns for transactional integrity. You separate transactional workloads from analytics workloads to protect performance and reliability. Lifecycle and retention design prevents long-term legal and cost problems, and backup strategy must align to recovery objectives and be protected from tampering. Security patterns combine least privilege, private access, segmentation, encryption, and strong key management, while integrity controls ensure data remains trustworthy over time. Resilience design for data aligns to recovery time objective and recovery point objective, and cost governance ensures data platforms remain sustainable. Finally, clear governance and ownership make data decisions accountable, consistent, and auditable across the enterprise. If you want your Azure data platforms to be secure, resilient, and scalable without becoming a cost and compliance nightmare, subscribe so you can continue through the rest of this playlist and complete the enterprise Azure architecture journey. Like this video so more leaders and architects learn practical data architecture patterns. Comment with your biggest data challenge such as backup strategy, data store selection, or governance ownership, and share this with your team so you can align on a consistent data architecture approach that protects the business while enabling modern outcomes.